Hello everyone, welcome to BGP EVPN VXLAN lab course. In this particular unique course, we are going to configure the VXLAN over Catalyst 9000 switch. Now, you may familiar that this particular feature, BGP EVPN feature, we can go and configure over the Nexus switches. But Cisco has introduced the feature that you can go and enable these capabilities in Catalyst switch as well. And that's the reason we have this particular lab. Now, if you do not know that when we are using leaf spine architecture within the data center or within the campus network, what are the benefits we have? So if you go and use this within the data center, within the campus network, the benefit we have in the leaf spine structure is this, that in that case, if you need port capabilities, you can seamlessly go and increase the number of leaves. If you want the aggregators, then you can go and increase the number of a spine, right? And that's the main reason the evolution of data centers, that in modern data center, all the SDN fabric, all the SDN network, for example, Cisco ACI or NSXT or VMware, they are using or they are supporting this leaf spine structure. And then the same capability now we have in the campus area networking as well. So what I will do, that in upcoming two videos, you will go and understand the capabilities and features of VXLAN. So I have recorded two videos for VXLAN. You'll understand the terminologies used within the VXLAN, what are the advantages we have in the VXLAN, and then you can continue follow the process, that how we have our lab in our lab, uh, where we have the spine leaf, border leaf, and how things are connected. So please go and continue this particular course. This will be very informative. You will learn that how to use a BGP, EVP, and VXLAN within the Catalyst switch. In the coming 2 to 3 videos, we'll learn about the VXLAN. Now the question is that what is VXLAN? VXLAN is nothing but virtual extensible local area network, where we are extending L2 capabilities over L3 tunnel. Okay, so we'll learn about this, that how we can extend it, and for this extension we are using UDP headers, and we'll see that the VXLAN encapsulation as well in the upcoming recordings. So suppose you have your physical infrastructure like this. Say you have devices, say in data center 1, 2, 3 or branch 1, 2, 3. Suppose this is A, this is B, this is C, this is my underlay, and suppose if I build overlay. So here you can see that I can build VXLAN overlay on the top of my underlay, and then you can see here that I have something called VTEP. VTEP is nothing but the VXLAN tunnel endpoints, and then I can communicate from one VTEP to other VTEP. Okay, now there are so many new terms. You can see here that the VTEP, the VNI, VNID, all these stuffs. I will explain all these things one by one. Now if we use VXLAN, then what benefits I have? You can see that in the classical Ethernet, the VLAN capability, or the what you can say, the number of VLANs that you can use is a 4K. It's a 2 to the power 12. That means this much. Now here the capability is enhanced drastically. Here we can use VXLAN 2 to the power 24. That means it's a huge number. Okay, so one thing that we have increased here, that's the number of VLAN we can increase. Okay, that's the one thing. The second thing, that it allows layer 2 multipathing, and that is very much similar to the fabric path. So in fabric path also we have you can say what, that we have layer 2 routing capabilities. So once we introduce routing inside MAC addresses, that means it will give the same feature that we have with the routing, Okay, so that's why we have this layer 2 multipathing. It is supporting clause fabric. So we may know that we have fabric structure like leaf, spine, and then again leaf, and then again a spine. Logically, all the gateways, they are connected by one hop. So from one leaf to other leaf, I can go like this. I can go like this. It's like a clause fabric that you are always one hop away, or your gateway is say one hop away, like that. Includes a scaling enhancement. Yes, correct. So once we use this type of strategy, the scaling will increase. Now the other stuff that we can see here, that optimized control plane, that is MAC learning, ARP table, BUM, that is the broadcast, unicast, multicast replications, does not break layer 2 adjacency requirement. Okay, so this is again one of the feature that it optimizes the control plane. Then allows for any to any stateless layer 2 layer 3 transport, that is vMotion. So we know in the next generation data center, we are very much concerned about say not only the north-south traffic, but we are very much concerned about the east-west traffic as well. Okay, and in that scenario, we are using vMotions as well. So once we are doing the vMotions, say from one data center to other data center, at that time the capability is stateless. Okay, simply we can uh, drag and drop the vMotions. There is no problem on that. Then finally you can see that allows for multi-tenancy. That is again one of the capability of this VXLAN. Separation of customer traffic over shared underlay fabric, because we are using something called the overlay underlay concept. So here we can logically divide the traffic, we can create multi-tenancy, we can have the features of say VRF, where we can segregate the customer traffic. Okay, then finally you can see that allows for overlapping L2 and L3 addresses, that is VLANs and IP addresses are locally significant. Okay, so because we have the VTEP endpoints, so locally I can reuse the IP addresses. So not only the IP addresses, but we can allows for overlapping of L2 and L3. So MAC address and IP addresses we can reuse. So these are the features we have in my VXLAN. You can see that there are lot many features. Not only we have the address space, multipathing, enhancement in the control plane, reusability of layer 2, layer 3, but we can create the multi-tenancy and we can segregate or separate the customer traffics as well. Okay, so let us quickly discuss about the VXLAN terminology. The first terminology we have is the VXLAN overlay. What does it mean by overlay? Now here you can see in the definition that overlay or VXLAN segment is a layer 2 broadcast domain. Okay, and the identifier for this layer 2 broadcast domain is VNID, that extend tunnels traffic from one VTEP to other VTEP. Now simply if you want to understand this, that under the underlay we have the overlay infrastructure, and this overlay infrastructure, where to where we want to communicate. So we want to communicate from VTEP to VTEP, correct? And this VTEP to VTEP is nothing but the layer 2 extension, and these VTEP to VTEP are nothing but tunnel endpoints. Okay, now to identify these tunnel endpoints, we have something called say VNID. Okay, we'll see in the next recording that what is the significance of VNID, because VNID is something which will provide you the identification of the VXLAN. We'll see that in the upcoming section. The next we have the VTEP. Now the VTEP device that provide both encapsulation and decapsulation of classical Ethernet and VXLAN packets to and from the VXLAN segment. That's correct. So VLAN, they will provide encapsulation, they will create tunnel, they will send to the other VTEP. From there they will do the decapsulation and vice versa. Now what type of interfaces are there? The switch port interface on local LAN, layer 3 interfaces, SVI interfaces. Correct? Then we have VXLAN gateway, obviously a VTEP that bridges traffic between VXLAN segments. So whenever you are bridging the traffic, you need gateway, okay, and you can define the VXLAN gateway. Now finally VNID, we'll discuss more about this VNID in the upcoming sections. Here also you can see that it's a tag, okay, given to every VLAN which need to get extended over VXLAN. Every VLAN between the DCI which is extending will be mapped with a valid VNID tag. So suppose if we don't have this VNID tagged map or this tag value mapped, then we can't extend the VLAN from one DC to other DC, one data center to other data center. This is manually defined on all the VTEP participating in the VXLAN. So that means that this is a configuration and it should be manually defined from all VTEP to all VTEP or from all data center to all data center to extend the VLAN. Okay, so this is the tag value. VNID is nothing but the tag value. Okay, and it is used to extend the VLAN from one data center to other data center. Then finally we have NVE, network virtualization edge. It's a logical representation of VTEP. This is quite obvious. So whenever we are creating some logical interfaces, because see this overlay, so we have underlay, and on the top of this underlay we have overlay. So whenever we are talking about any type of overlay strategy, either it's OTV or any, there are so many overlay strategies we have. Whenever we are defining any overlay strategy, at that time we need some logical interface. In this case, in case of VXLAN, we have NVE, network virtualization interface, and that is the logical representation of VTEP. Okay, and then finally we have the underlay. Underlay means our physical resources where we are running OSPF, EH, ERP, ISIS, etc. Okay, so these are the overview and VXLAN introduction. In the next section we will learn about the encapsulation of VXLAN. Okay, let us learn about this VXLAN encapsulation. In VXLAN encapsulation, you can see here that it is adding 50 bytes of overhead, 8 bytes for VXLAN header, then 8 for UDP, then 20 for outer IP header, then 14 say for outer MAC header. Okay, so let us discuss all these headers one by one. When we are talking about VXLAN header, we have say 1 byte or 8 bits for VXLAN tag, and you can see here in the diagram as well that R represent say reserve. So 7 bits are reserve and 1 bit is 1, means it is set as 1. That means that VXLAN is on. Okay, then we have 3 bytes reserved for future purpose. Again 1 byte is reserved for future purpose, that also we can refer here in the diagram. But we have 3 bytes, that is the VNI, that is the VXLAN identifier. Now this is a value which is mapped with the VLAN. So here you can see in the Nexus 7K, when we are defining a VLAN in terms of bridge domain 10, at that time member VNI is 10101 is a number. Actually it can be not 3 byte. That's the significance actually. So whenever we are talking about 3 byte, that means we have 24 bits, and this much number of VLANs that we can create, that is 2 to the power 24. So this is the actual number. Okay, and that number is coming from VNI. In Nexus 7K we can configure like this. In Nexus 5K or 9K we can configure like VLAN 10 and then the VN segment 10101 like that. Okay, so this is actually the significance of the VNI. Then we have the outer UDP header. Now again, this is very interesting here, that for outer destination UDP the port number is fixed 4789, but for the outer source UDP port it is the hash value between port number say 49152265535. Okay, this is actually very interesting. This particular 8 bytes are derived from this calculation. Then we have outer IP header. Outer IP header is easy. The outer source IP will be the L3 IP address of the VTIP, okay, which is doing the encapsulation for VXLAN. So this outer source IP is actually your IP address, your VTIP, that from which place you are doing the encapsulation. Now there is Cisco recommendation that you can use the loopback addresses for that. Okay, because obviously we know if the physical interface will go down, then everything will go down. But if you are using loopback address, means it can associate with n number of physical interfaces. Okay, so this recommendation is not with VXLAN. This is for all the overlay technologies. So for all the overlay technologies, you please do not associate your physical interfaces. Think that you are making your overlay over the box. Okay, so for one box, if there are n number of interfaces, doesn't matter, you create one loopback interface that will represent this box as a VTIP. Okay, great. Now the outer destination IP address will be L3. So this was the outer source. Now we have the outer destination will be the L3 IP address of the destination VTIC in case of unicast traffic, but it's a multicast IP address in case of bump traffic. So this is again important, you can make a note, the unicast and multicast association. And again in case of MAC addresses as well, the outer source MAC address will be the MAC address of the source VTIP, but the outer destination MAC will be the next hop L3 device MAC address in case of say unicast traffic, or multicast MAC address in case of bump traffic. Okay, so the analogy for IP and the MAC is the same. So source is your IP, your MAC, but the destination is the multicast if you have bump traffic, or the next hop, obviously next hop IP address if you have the unicast address. Okay, again we have some logical representation or the frame format. Here you can see that this is the actual Ethernet that is getting encapsulated inside VXLAN, the 50 bytes of header. So I have 8 bytes of VXLAN, then 8 for UDP, then 20 for IP, and then 14 for MAC. Okay, and here inside VXLAN we have reserve values, we have reserve value, we have this one what you can say 8-bit, or actually it's a 1 bytes, but it's okay, 8-bit. Out of those 8-bit I have 1 bit set as a VXLAN identifier, and then the most important thing we have is the 24 bits actually. So that will give you 2 to the power 24 VLAN ID capabilities for the VXLAN header. Okay, and then we have already discussed about the UDP and the IP and the MACs. So this is the overall frame format. Again we'll see this here in the detail, that all the frame, all the bits you will find here. So let's quickly complete this. I have this VXLAN header. Inside this VXLAN header you can see that one bit is reserved. Again the same thing that we are talking on and on. Then the 3 byte reserve, then the VNID, that is the 16 million possible segments, then the reserve bit, this now we know. Then for outer UDP, this is fixed 4789, but the source will be derived from the port numbers that we have mentioned earlier. Then we have outer IP address. Here also we can check what is the source IP and destination IP. Then we have outer MAC header. Here also we can check what is the source MAC and the destination MAC. Okay, so this is the VXLAN encapsulation and the detail about this VXLAN encapsulation. This is the overall topology for our leaf, spine and border leaf connectivity. Here you can see that different portions. So let me quickly go and highlight that we have different portions in this topology. You can see the spine 1, spine 2. Then we have leaf 1, leaf 2, leaf 3. They are connected with the end host. And then these end hosts, they want to do communication to outside world. They will go via the access leaf spine, and you can see the border leaf connectivity we have, where they can go and reach to the different website. So first of all, I will go and do the configuration for a spine 1 and a spine 2. You can see various interfaces here connected from the spine and leaf and border leaf, and you can see various loopback addresses in a spine 1 and 2. So let me quickly go log into spine 1. Let me quickly show you the existing configuration of a spine 1 and 2, and then we'll go and add the rest of the configuration. So if I go to spine number 1, and if you go to show IP int brief, just to see that what are the interfaces and IPs configured, you can see here as per the topology. So let me show you the topology as well. Spine 1, side by side, we can see the topology. So we have management interface, then we have gig 101, 2 and 3. So 1 and 2 and 5. So 1, 2 and 5. And maybe I need to check the topology once. Let's do this thing. Show CDP enable. The interfaces may be wrong in this diagram. It should be 1, 2, 3 like this, but let's see. So once we come here, you can see that leaf 1, and you can see leaf 2. So we can see leaf 1, leaf 2, and leaf 3. So the topology is correct. It's connected with leaf 3 is connected with 5, leaf 2 connected with 2, and leaf 1 is connected with 1. So this is correct. And then 1 and 3. So you can see that border leaf is connected to 1, and then you can see border leaf 2 is connected to interface 4. So this topology correct, and according to that we have IP addresses configured on these interfaces. Now what we want to see here, if you go and check the individual interface configuration. So if you go and check the interface configuration for 1, 2, so clearly you can see here that we have OSPF in area 1. They are OSPF network point to point, and then further you can see that we are running p-min sparse mode. Actually, that is all the interfaces. So if I go and simply do show run, where you can see all the configuration here. So the default configuration, and then you can see loopback 0, 1, and 2.
Then you can see management interface. Then you can see the interfaces 1, 2, 3, 4, 5. The border leaf interface also you can see. So within the border leaf, almost the configuration is same, correct? So border leaf interfaces are 3 on 4, and you can see the configuration. There also we have OSPF in point to point, OSPF in point to point. So IP is 7 and 8 for that. Now we have the base infra configured here. Now what we want? We want to enable BGP here in a spine 1 and a spine 2. And that BGP peer later on will go and configure for our access switches. So here if you go and see the diagram here, I haven't shown that where is OSPF running, where is BGP is running. So those informations are not there. Seems the devices are timing out. Those routing protocol topology information is not here, but later on you will see that which autonomous system that is spine, access switch and border leaf they are running. They are actually running AS, BGP AS 65000. We'll see that slowly in this. So what we want to do here is this, that we want to go and do the BGP configuration for this spine, right? Now, before starting the BGP configuration, and make sure that we have clear understanding of the topology, and we should know the basic configuration related to the OSPF and PIM that is running here, right? So now we have this configuration, and next I will go and restart all these network devices, so this error will not come again and again and again. So let me go and restart all these devices with basic configuration of the spine 1 and spine 2. Likewise, we have configuration for a spine 1. You have the basic configuration for a spine 2 as well. The OSPF and PIM in a sparse mode is running, and we have loopback 0, 1, and 2. What are the use cases of those loopback and all? We are going to discuss more and more about that in the upcoming section. So let me quickly go and stop the recording here, and next section will go and do the BGP configuration for a spine number 1. All right, so in this section, we'll go and do the BGP configuration for spine 1 and 2. All these spine leaf and border leaf, they are running with AS number 65000. So let's go and do the BGP configuration for spine 1 and 2. And later on, slowly, I will understand the rest of the configuration in upcoming section. So I can go to spine 1 and I can start BGP 65000. We'll go and use the template for the policy, and this will be the same template feature that we have a policy we have for all the devices. So we are going to use EVPN, peer policy is just the name. And in this template, route reflector client, because both the spines, they are working at a RR route reflector. And then we can go and do software configuration in inbound, and we must do this send community both in and out direction. Now we'll exit with this peer policy. Now we'll go and give the router ID. And router ID, we have the loopback address. Oops, router ID should be router ID 10.10.10.5 and BGP log changes, BGP graceful. Some of the configuration that I'm giving here, these are the default configuration. If you do not give this configuration, it will be there if you go and do show run section BGP, etc. IPv4 unicast, because we want to make this solution for other address family like EVPN and others. Okay, So this is very basic configuration related to BGP. Now what we will do here, that we'll go to the neighbor statement of the remote S, and let me quickly show you that where these loopbacks belongs to. So if you go and check the diagram, you'll see that we have the loopback addresses for access leaf 1, 2, and 3, and you can see the loopback address clearly is 10.10.10.0.1, 10.10.10.10.1, 2, and 3, right? So like that, we are giving this neighbor statement, and we know that they are part of same AS. That means we are running IBGP, and then we have the update source loopback 0. Same way we can go and run this command for 1, 2, 3, 6, 11, and 12. So let's quickly do this. So let's make this 2. Even we can do some copy paste as well. And then update source loopback 0. Then we can do for 3. Then we can do for 6, 11, and 12. So let me quickly show you that this is 11, 12, and spine 2 is 6, right? So what I will do, rest of the configuration, I'll copy and paste from the notepad just to save our time. So I'm writing this in the other notepad and putting here, right? Then we can exit from, okay, IPv4, oops, exit from this. Okay, we are exiting from the address family. Now we'll go to address family L2 VPN, right? EVPN. And there we have to go and give the information related to neighbor, because now we want to activate the neighbor, and then we want to send the community in and out, and then we want to inherit the template that we have created for the policy. So this is the overlay spine peer policy, right? And same way we have to go and do the steps for dot 2, dot 3, 6, 11, and 12. So what I'll do again, that I'll go and copy paste this configuration for the rest of the peers that we have, and let's paste here. Right. So now you will see that BGP configuration, I can exit from here now, and very much the same configuration we have to go and apply to the spine 2. Let's see the configuration. So what we can do here, that in a spine 2, instead of the peer that we are seeing 6, because 10, 10, 10, 6 is the neighbor. This is the spine number 2. So instead of 6, I have to go and put 10, 10, 10.5 in these places. The rest of the BGP configuration will be exact the same. So what I will do, I can copy this entire configuration. Instead of 10, 10, 10, 6, I'll go and put 10, 10, 10, 5, and then we'll go and paste this configuration. So let me do this in the back just to save our time. So I'm creating the configuration in the back, making sure that it should be 100% correct. Otherwise, things will not work later on. And again, we have to configure it. So now we can see the same thing that we tried to do here. Instead of .5, we are using .6, we are using .5, and putting the configuration here in the spine 1 and spine 2. Okay, so our configuration is almost done related to spine 1 and spine 2. All right, let's stop here. Now in this section, we'll go and configure the access leaf 1, 2, 3, and this configuration is related to BGP configuration. So let's do the BGP configuration for access leaf 1, 2, and 3. Let's log into access leaf 1. And for access leaf as well, we have some base configuration. We can go and verify that. So you can see the configuration over the interfaces as per the topology. So you can see the topology here in the back. That access leaf, access switches, they are connected with gig 101, 102. And then you can see that we have loopbacks created here. So they have the configuration here. And then we'll go and configure the BGP. So let's do the BGP configuration. As we know that all these devices are in same AS number. So let's go and do the BGP configuration, and you will see that the configuration related to BGP, you will find they will be almost same. So let's go to the AS, and then we have the template for policy, and I can copy and paste as well. And in this, we can go and do the same thing. Inbound and send community both. Oops. By default, it will be both only. And then we can exit. Now, let's go and give the BGP router ID that is 10.10.10.1. And then these things will be default only. So by default, these configurations will be there. Otherwise, we can go and put this. Okay. Then we'll go and do the BGP no for the default IPv4 unicast, and then we can go do the rest of the configuration. So 10.10.10, we know that we have two spine. So one spine address is 10.10.10.5. Remote AS is the same, and then update source loopback 0. Same way, we can do the same for the other spine, spine number 2, and then the update source loopback for other spine. Right, then we can go and exit from here. Then we can go to the address family, this time L2 VPN, EVPN. And the same command that we have done in the spine, delay is 0. And then we have to go and activate the neighbor. So 5 activate, and then the send community both, and then the policy that we have, via policy. Same configuration with .6 we have to go and put So let's do it quickly. This time this will be 6. Oops. This time this will be 6. And then this will be send both. And this time this will be 6. Now once we do this configuration, next thing that we can go and verify the BGP neighbor relationship. But before doing that, the same configuration, replica of configuration, we want to use in the other switch as well, other access switch as well. So what I will do that let's go and configure this part. Instead of 1, this will be 2, right? And rest of the configuration will be the same, right? Because you have common spine for all the leaves, we have common spine, so the uplink configuration will be the same. Likewise, again, I can go here and copy and paste the same thing to this, the leaf number 3. Instead of dot 1, it should be 3, and then the same replica of configuration we can go and put here. So now once our leaf 1, 2, and 3, they are configured with respect to BGP, because we have to go and do other configurations as well here. Now we can go and check the BGP neighbor relationship. So for that, we can go and check the L2 VPN configuration. Now I can see that they have the peer relationship with the spine. So let's go and do show BGP L2 VPN EVPN summary. There also it is up with 5 and 6. And here also we can go and check L2 VPN EVPN summary. So all these 3 access switches, they have the IBGP relationship with the spine. So leaf 1, 2, 3 have a configuration, means the uplink configuration is that IBGP relationship, and which is showing up and running. All right. So this is the part of BGP configuration. We have 2 section more to configure in the access switch. One is L2 VXLAN configuration, one is L3 VXLAN configuration, that we'll do in the next sections. Let's just stop the recording. In this section, I will go and configure L2 VXLAN for access leaf 1, 2, and 3. Here in the diagram, you'll see that the PCs that we have in below, they are connected with access leaf, and here they have something called local VLAN or VLAN associated with them is VLAN 101. So how the traffic flow will happen? If you go and consider the traffic flow, you will find that suppose if PC1 wants to communicate with PC number 2, then obviously they have to come and reach to leaf 1 with their local tagging VLAN, that is VLAN 101. And 101 wants to communicate with the other side local VLAN, for example, VLAN 102. But point here is this, that the fabric that you're seeing in between, that fabric is VXLAN fabric. So what does it mean? What it is telling here is this, that the encapsulation, the VLAN encapsulation, or the VLAN that we have, it will get encapsulated within the VXLAN fabric. So suppose if this fabric is nothing but the VXLAN fabric behind the scene. So we have VXLAN fabric in between the, let me shift this a little bit. So in between, actually that will be in between leaf to leaf, but the actual physical infra will be the spine, right? The connectivity will be via the spine. So what I'm doing here is this, that let's go here and draw two diagrams at least. So one is as it is, that whatever we have related to that AS, whatever we have, right? And it seems very, let me change the border. Okay, let me go and fix this. So border will be thin, and yeah, now you can see that you have BGP behind the scene, and then we have VXLAN fabric. And within this VXLAN fabric, what you will see that we have OSPF and PIM running behind the scene as a OSPF is running as a underlay protocol. So we have actually full reachability for this OSPF along with this leaf and a spine. And later on, we'll see the border leaf configuration as well. But let's just stick with the communication that we have here in between PCs to PC over the VXLAN tunnel or over the tunnel, right? So if you have to go and cross different leaf, you have to use the tunnels that will get created in between leaf to leaf, and that L2VNI configuration we are going to do now. Okay, so let's go and log into the access switch and let's do the configuration related to L2VNI. So here I am in the switch, and let's go and enable that L2VPN, EVPN. Replication type is static, and then the router ID is loopback 0 that we are using for BGP router ID as well. Default gateway we are advertising, right? Then L2VPN, EVPN instance. We know that this VLANs, they are local, and then the encapsulation is VXLAN. Now the VLAN configuration 101 is member of any of the EVPN instance VNI, for example, this. And we are very much good. Now, only thing that we have to do here is to go and create the NVE instance. So NVE interface 1, because here we want the source interface loopback 0 that you can refer the topology diagram. Host reachability that we have, that protocol is obviously BGP we are using here. And finally, the member VNI for 500101 MCAST group, we can go and give any number. Okay, so like that, we have to go and do the configuration related to EVPN. So what we are doing, that EVPN configuration, and then L2 EVPN instance configuration. Then we are putting the VLAN configuration, and then we are putting the VNI configuration, right? So that is should and include interface NVE 1. So point here is this, that we have to go and do the same type of configuration to the other switches as well. So what I will do, that I will go and copy this, and in the other switches we have to go and put this information. So if I come here, you'll see that here is 101, but access leaf 2 having VLAN 102 that we need to change. And here we can see 101 and 102 both. So small changes in the configuration will be there, but most of the configuration items will be very much same. So we can copy this configuration. Instead of 101, what you need, your instance is 102 VLAN. So that's a problem. It should exit and L2 VPN EVPN instance 102 VLAN paste, and then encapsulation VXLAN. Oops. Exit interface NVE 1, and we can go and put the same information here. Instead of .1, we'll go and put .2 here, and then exit, right? Likewise, we have to go and do the configuration for access leaf 3 as well. So access leaf 3, where we have VLAN 101 and we have VLAN 102 as well. So like that, we have to go and prepare the configuration. So here we are. Here we are. We should put some configuration related to the VLAN base. That's correct. Okay. So let's go to access leaf 3, and here also I will go and configure it. So let's do L2 VPN EVPN static router ID loopback 0 and default gateway advertise exit L2. So what I'm telling here is this, that EVPN instance VLAN based encapsulation VXLAN, like that, because there are two VLAN 101 and 102, and encapsulation is VXLAN, like that we have to do exit. And finally VLAN configuration for member EVPN instance 101 VNI 50101, and then VLAN configuration 1102 502. Oops. 1 VLAN. This is not 1, this should be 2. Okay. And then we'll go to interface NVE 1. Source interface, that will be loopback 1, host reachability, protocol BGP, and finally member VNI 50101. MCAST is 238, that we know. 111. Like that, we have to go and do the configuration for access leaf 1 related to L2 VPN, related to L2 VPN EVPN instance, VLAN configuration, and finally the NVE interface. So we have done the configuration related to L2 VPN, but this is, you can say that this is L2 type of VXLAN configuration. In next section, we'll go and do the configuration related to L3 VXLAN configuration. In this video, we'll go and configure L3 VXLAN for access leaf 1, 2, and 3. Now, this configuration will be a little bit complex because we have to do various configuration related to L3 VNI, related to how we are going to import, export the L3 VNI. Again, we have to go and do this configuration within BGP as well. So let's do one by one slowly. What are the pieces of configuration we want to do here? Now, first of all, let's go and define the business unit in terms of VRF that we want to create within this system, because we can go and create different type of VRF for different type of user. That is one of the capability we have with the VXLAN. Let's give the RD route distinguisher, and then address family. This is for IPv4 route target export and route target import. Now, few of the configuration within all these access leaf will be common. So we don't have to actually very much mug up with all the configuration items within all the access leaf, because some of the configurations may be actually 100% of configuration will be same, but you have to go and change the gateway IP and some of the variables, right? Few of the configuration you will find same, because that will be the configuration for the leaf and spine and the global parameters. Few of the configuration which is interface specific, where we have to go and change the VNI numbers and the VLAN numbers and the IP addresses, right? So we want to stitch this, and even in the import as well. So import and export, we want to stitch this. Now, in case if we have address family related to IPv6, and there also we want to do the same thing. So let me go and quickly copy and paste these configuration items. I can use my putty and can do that. Okay, address. So again, I have to go to VRF definition prod, address family IPv6, and route export, and route target import. Exit. Like that, we have done this. Now let's go to VLAN configuration for L3 VNI. This is member of L3 VNI. What was the number that we are using earlier? 501000. We have the list of L2 VNI and L3 VNI that we can go and summarize. Let's exit from here, go to interface VLAN 101. And we can give some description here that VNI 500101 that we have used earlier, default gateway. And here we have to give the forwarding for prod, and we'll go and define the default gateway here. IP address is 198.168.101.1, because the PC that we have, PC1 that we have in the diagram, whose IP is 198.18101. Maybe 10 or 11. So likewise, we are defining the gateway here. Now we'll go to interface VLAN 1000. That is my L3 VNI. Oops, not 10,000, 1000. And here also I can go and give the description. This is core SV for L3. Yeah, this is L3 VNI. That's the description. And VRF forwarding prod. I'll use the unnumbered command, loopback 1. Okay. And no auto state. Great. Now, once we do this much of configuration, we are very much done. Now we have to go to interface NVE that we have created earlier. And in NVE1 interface, we have to assign this VNI. So let's quickly see that. Show run interface NVE1, what configuration we have. So within NVE, you can see that we have member VNI, that is for L2 VNI mapping. Now we should go and map this 1000, 10, right? The L3 VNI with the VRF prod. Basically, what is happening behind the scene that if you have local in terms of if you have local communication, then these VLANs will communicate within the same gateway. So if communication is within the same gateway, then L2 VNI will come into the picture, like normal L2 forwarding will happen. But if you cross your boundary from L2, suppose if I'm moving from one VLAN to other VLAN or one L2 VNI to one other L2 VNI, then this L2 VNI across the border, they should go and stitch to L3 VNI. And from there, the routing will happen. Again, this is a normal routing only, but we have to go and add the configuration line items. Then finally, we'll go to router BGP 6500, where we have to go and move inside the address family related to that particular VRF. And then here we'll advertise L2 VPN, EVPN, then redistribute the static, redistribute the connecting, and if you want, we can maximize the paths for IBGP 4. So this sort of configuration we have to do, right? The same sort of configuration we have to do within the access leaf 2 as well. So what I will do, I will go and copy and paste the same configuration line items, which is common within 1 and 2. Only we have RD101:2 route distinguisher. This portion, rest you can see stitching part, everything is same. The L3 VNI is also the same. Then in this case, we have interface VLAN 102 that we have defined, right? Description will can go and give that VNI 5010, VNI 500 102 as default gateway. We have to go and define the default gateway here. That is first of VRF forwarding is broad and then IP address. In this case, the host machine having IP address in the range of 10.10.11.12 like that. So the default gateway is 102.1. Then we'll go to the interface VLAN 1000, where we have to define the L3 VNI. So the description is core SV for L3 VNI. Like that, we can go and give the description, prod, and then IP unnumbered, loopback 1, no auto state, interface NVE1. Here also we have to go and assign this VNI 50100 is L3 VNI to VRF prod, and then router BGP. Same way, address family IPv4 VRF prod, And then we have to advertise the L2 EVPN, and then redistribute static, redistribute connected, and then we have to go and if we want we can maximize the path for IBGP4 and then exit. So now you can see that access switch 1 and access switch 2 having very similar line of configuration. Even access switch 3 also will find same line of configuration. Only a few places we have to go and do the changes. So what I will do, access leaf 3, the same configuration item, we can go and utilize it. So here RD is 101:3. Rest of the configuration you can see almost same. What we are doing here is this, that again we are going and doing the L3 BNI configuration, then giving the description, auto state, everything is right. Now we'll go to the interface VLAN. Here we have 1101 and then we define the gateway. So VNI 500.101 default gateway. We are forwarding prod 101.1 1102 same configuration, almost same that whatever we have done in leaf 1 and leaf 2 we are doing here. And finally we have to go to NVE1 interface. We have to define the VNI, same thing that we have done earlier for VRF prod. And then finally router BGP 6500. We have to go to address family IPv4 VRF, that is the prod, and then advertise L2 VPN EVPN, and then redistribute static, redistribute connected, maximum path for IBGP is 4, and then exit. So we have done we have done full configuration related to our VXLAN, related to access leaf 1 to 3 and spine 1 and 2. Now what we can do here, that we can go to the border leaf 1 and 2 and we'll do the rest of the configuration, and then we can verify the connectivity, verify the BGP endpoint learning, all those testing and troubleshooting we can do. All right, let's just stop here. Before moving further, let's do the verification. So what we can do, we can go to the access leaf and then we can verify the type 2 and type 5 routes. So let's go to the access leaf 1 and let's see that what type of routes it is expecting or it is receiving. So here we can go and check BGP with EVPN, that's L2 EVPN summary, and now we can see that it is receiving 6, you can see 6 prefixes. Now instead of summary, if we type question mark, you can see we have good amount of options here. And if we go and check route type 2, now you can see that we have route type 2 and we have details about route type 2, the MAC address and the IP addresses. You can see all those details we have. Now if we go and simply, okay, let's do route type 5 is basically it's L3 VNI routes. And if you want to see the summary of these routes, simply go and check the EVPN. except summary, and you can see type 2 routes and type 5 routes as well. Now these type 5 routes that we are receiving here, 101:1, this is self-generated, and that's why the self-generated means 000, next hop is 000. Then you can see clearly 101:2 and 101:3, and you can see that the routes receiving, they having this subnet because this belongs to VLAN 102, and then from other leaf, so this is from leaf 2 and this is from leaf 3, that they are getting the route exchange. This is something like getting from the other leaves, learning the endpoints from the other leaf. And apart from that, you can see that we have type 2 routes as well. In these type 2 routes, you can see clearly the IP address of the endpoint that we are learning, 101.11, and then all these routes. Now, let me quickly go to access leaf 3, and here we can do L2VPN, EVPN, just to see this routes that we have. 101, you can see 102.11 as well, 101.10, 102.11, and then you have type 5 route coming from, this is self-generated route, VRF is prod, and then you can see the leaf number 2, access leaf 2, access leaf 1. So yeah, it is receiving the routes, and if you want to see the VRF, means the route within the VRF, so then you can go and check show IP route. VRF is prod, and I'm not receiving this. Let me go and check show IP route VRF prod. Here I can see show VRF. We have this prod VRF. Show VRF. We have the prod VRF. Right, so this is the way that we can go and do the verification. Let's just stop here. In this video, we'll go and do the configuration related to border leaf. Then in that case, that how PC1 or PC2 will go and reach to the gateway. You can see that border leaves, they are connected with internet or the outside world. How the communication will happen, we have to go and do the configuration here to border leaf, so that these hosts, these end host PCs, they can go and connect to the internet. So we have to understand the pieces, that what are the important configuration required, that this fabric network will go and communicate with the outside world. So let's go and log into border leaf 1 and 2, and let's do the configuration. So let's go to border leaf 1. The way that will go and configure border leaf 1, almost similar fashion, we have to go and configure border leaf 2 as well. First of all, I'll go and create the IP prefix list that will go from BGP. We know that the external word communication that we have to do is from BGP to OSPF. And let's give the sequence IP prefix list. IP prefix list sequence. Sequence 10, not SCP. Permit, we know that the end host machine, they have IP in the range of 101 and 102. So in sequence number 10 and 20, we can go and give 101 and 102. And then we'll go and create one more prefix list that is for default route. default route with sequence 5, where we want to permit 000/0, and then we'll go and create the route map. Let's give the name, allow the default permit 10, where we want to match the IP address, that is prefix list, that is the default route, or simply we can copy and paste as well. So the statement that is we have with route map. So we are creating actually two route map. One is for default, allow default, and other one we want to create that will be BGP to OSPF. That's the name, permit 10, and match IP address prefix list. That is the prefix list BGP to OSPF. Now we'll go to gig interface 103. You can see the configuration here. Nothing is configured here. We'll go here and we'll do VRF forwarding prod. VRF is not configured here. We have to go and configure the VRF and VRF definition. Otherwise, this part of configuration will not work. So we need to do that configuration first, actually. Let's do that. So VRF definition prod, and same type of configuration we have done to the access leaf earlier, 101.11, as per the router ID or the loopback address last octet we have. Like that, we have put 101, 1, 2, 11, 12, etc. Then address family IPv4, route target export, and route target import. Then with import we need a stitching, and with export we need a stitching. Then address family IPv6, and the same things we can do, import and import stitching, export and export. Like that we can do. Then we can do this VLAN configuration, member VNI, that we are doing in the access leaf as well. Then we can go to interface VLAN 1000, that is our L3 VNI. Description is core SV for L3 VNI, right? Then VRF forwarding for prod. Now it will work. IP unnumbered loopback 1, not a state. Then we can go to interface NVE 1, source interface loopback 1, host reachability protocol is BGP. Very much same type of configuration that we have done for the leaf switches, access leaf switches. Same type of configuration we are doing here. And then we have to go and do this in router BGP 65000, address family IPv4, VRF prod, advertise the L2 VPN, EVPN, then redistribute static, redistribute connected, right? And the maximum paths IBGP 4, and then we can exit. Right, so 100% same configuration we have done earlier as well. Now what we can do that because we are doing all this configuration, why not let's go and complete the configuration related to BGP. So we are inside the BGP where we can go to the template, and if you go here, see the BGP, we have this template. So like same configuration we are going to use. And we can go to border leaf template. Within the BGP, we have template peer policy. Name is overlay spine, EVPN, peer policy, and then all those things like soft configuration, inbound, and then send community is very important command. Both exit the peer policy. Then we can go to BGP router ID 10, 10, 10, 11 is the router ID. Rest of the things, actually they are by default, it will come. And then we have to go and give the neighbor command that we are giving for the spines. Actually the same configuration. Why not? Let's go and copy and paste. And then I should go to the EVPN address family. And then also we can go and configure it. So why not take this configuration and go to border leaf, put this. Right. Now I can come back to the border leaf view over the interface Kiki 1/0/3 that we are doing earlier. Now we can do VRF forwarding prod and then IP address 198.168.174.125.255 192.0 IP OSPF area L0, right? And then a router BGP 65000. We have to go inside the address family IPv4 VRF prod, where we can do default information originate, and then we can redistribute the OSPF with the route map, allow, default, right? So now you can see this configuration. Only new piece here is this, that we are creating this configuration allow default, so inside can go outside, right? And what we are doing that we are going to BGP, right? And within BGP, we are allowing, or we are putting the default route. Likewise, we can go to router OSPF 1000 with VRF prod, right? We have the router ID here. Right. And let me see if I have done something here. Okay. Router ID for BGP should have correct configuration, but you understood that what are things I'm doing here. So that's very much fine. If some mistake in router ID, we can check later. Okay, and what we want to do here is this, that we want to redistribute BGP 65000 with the route map that we have created earlier. BGP go to OSPF, right? So now we'll see the route map BGP to OSPF. So basically what we are doing is this, that we are injecting the default route within the BGP, and then we are adding the specific route from BGP to OSPF, right? Now in this case, now if you go and check show IP route for VRF prod, now you can see that clearly we have the default route here, right? And now you can clearly see that we are receiving the 101 and 102 BGP routes as well, right? This is type 5 route coming from L3 VNI. So both way redistribution is happening. Let's go back here to the diagram. So what we are doing, that we are injecting the default route, right? We are injecting the default route coming here, going to the fabric in this direction. And then this is actually from the perspective of injecting the default route that is going into the BGP. And for that, what we are doing, we are going to BGP, and because you know that we are running BGP and OSPF, so within border leaf and a spine, and again from border leaf, everything is within AS 6500. So all these routes that we are receiving from this internet, right, they are getting injected. So we are going to BGP, and then we are redistributing the OSPF and allowing the default route going in this direction, right, in this direction, right? Now, secondly, what we are doing is that the OSPF routes that we have. So OSPF, we know that we have IGP running as OSPF. So OSPF routes, they are again going outside, but those OSPF routes are very specific OSPF routes belonging to 101 and 102, right? So we have 198, 18, 101 and 102. That is further going from OSPF to BGP, from inside to outside, right? Likewise, this redistribution is happening here. Now, once we do the redistribution, now you can see the type 5 routes that the border leaves they are receiving, correct? And apart from that, we can go and check the NVE peers as well. Let's see the NVE peers. So I can see clearly that we have L3 control plane, which is building with 101 and 102. That is something that we are expecting. Okay, so what I will do now, that let's quickly go and do the configuration for border leaf number 2. So let's go here and let's see border leaf 2 if we have. Here we have border leaf 2. I can go to border leaf 2 and I have the configuration backup for border leaf 2. I can simply go copy and paste. Oops. Border leaf 2 configuration is also very much same. Right, then border leaf 2 BGP configuration. Let's go and do the border leaf 2 BGP configuration. Exit from here and let's put the BGP configuration. Then we have border leaf 2 route exchange or external routing configuration. So let's go and add that piece as well here. Once all this configuration will get added, now if we go to PC1 and if we ping to google.com, let's try to reach out the outside world from here. Now we can see that we have the reachability to google.com, and it's a little bit slow. Let me break this and let's try to do trace. If I can trace the path to google.com, I can show you that how they are reaching. So this is connected with access leaf 1. From there it will go to the spine, and from border leaf and then the internet. So multiple hops it has to pass, but again how the communication is happening from the inside fabric to outside, that we can go and trace the path and we can check that. But point here is this, that we have done the configuration. Now we can see that we have the control plane with the other border leaf as well. So I have with leaf 1, leaf 2. Somehow some configuration is there which is not maybe working with access leaf 3, and that's why it is not coming up. Let's check the PS. Yeah, so only with 101 it is showing, or maybe some IP information is wrongly hard coded. Some small configuration mistake will be there, but anyways the overall agenda is fulfilling, that we are able to do the connectivity from inside to outside, even from one PC to other PC also you will reach. So let's go here, and if I can get the trace information, trace path, so trace path www.google.com. Okay, localhost path MTU, no reply. It will take some time, and meanwhile let me go to PC2. It is connected with leaf number 2, right? Access leaf 2. And if we go and ping 198.168.1.3 101.12. So its IP here, you can see that IP address is 102.10. So why not, let's try to ping 1.2.11. It is unreachable because the fact here is that the other access leaf 3 is not participating in this because it has some configuration issue that we need to resolve and do the testing. So only problem may be while copy paste the configuration, we have put some extra configuration in that, so it is not working. So let me go quickly and try to reconfigure the access leaf 3. Access leaf 3 here, it has some issue, it's not working. So L2 VPN, EVPN summary. Let's see the BGP. It's retrieving the prefixes 5 and 6. That is both the spines. And let's see the BGP configuration. So 5 and 6. And then the EVPN configuration. then we should go and verify the L3 VNI configurations and all. So let me quickly go stop the recording, try to fix this particular configuration, and we'll verify the rest of the things. So after pushing all those configuration, you can go and check the NVEPLs on these border leaves. And you can see that we have L3 control plane built with 101, 102, 103, and 112. That is the other border leaf. Likewise, here also you can see the control plane is building right. We can go and check to the access leaf as well. The control plane, L3 control plane and L2 control plane is building correctly. Apart from that, we have other outputs as well that we can go and check. Show BGP, L2 VPN, EVPN. Summary, we are getting more prefixes. And then we can go and check L2 routes and L3 routes. So here you can see that border leaves, they are receiving the route distinguisher 11 and 12, and these are the routes we have seen earlier that they are receiving all L3 routes, that is nothing but type 5, and then L2 routes with the MAC addresses as well, right? So this is the way that we can go configure, and finally we can go and do the verification. All right, let's stop here.